everybody. Today let's talk about pressure dependent VAV boxes. So if you don't know, a pressure dependent system doesn't use velocity tubes on it. It just opens and closes the damper based on room temperature. It does not care about airflow. And that's not a standard option here with Johnson. As you see, we can do a VAV box here. Our only options are single duct, dual duct, or subordinates. Even when we go through the question and answer here, nothing talks about pressure dependent versus pressure independent. So how do you get a pressure dependent? Well, that's easy. PIVAV. You can actually use side loops to get your pressure dependent. Just to get the side loops alone, you can go to custom applications and click through next and finish, and you have a blank starting page here, blank canvas to work on. We can go up to side loop here, and what are we going to do? Well, temperature. We'll use a number of inputs. We'll go ahead and create one since we don't have one. Feedback control, yeah, that's what we want. We could set it for cooling. Even if the unit has heating, we can make this work here. So let's just go here. We're going to call this cooling damper. Actually, we'll just call this damper command. Hit OK. And it's going to build some logic for you, no problem. We're not going to use this. We're going to go ahead and create our own here. And I'm going to search for damper, and I'm going to go down to find supply damper integrated, because that's what I need for it to go. And all I need to do to tie this together is go back to here and tie this to our damper. Once we do that, we can delete this guy. It's done. Okay. So now we have our damper command there. And this will work for cooling. If we had a network sensor, we could easily change this to a network sensor. We can just do modify signal, SA bus. No. To get the SA bus, to modify this to an SA bus, we just go and create another one right here. Add device. At the bottom here, we got our NS 8000s. And we got a zone temp. Say we got a zone set point too. Add device. There we go. So now I can take this zone temp that's coming into this program and change the connection to my zone temp here. And I can even use the set point off of the thermostat. Change connection, set point off of thermostat. There we go. So now I'm not using this guy at all, so we can get rid of that. Not using this guy at all, so we can get rid of that. All right. Now, if we had a cooling only VAV, this is all we need to do. Well, other than go to state tables and tell it when to turn on and off, but that's all we had to do. Now, if we had a unit that actually put out heat as well, let's just say we have a duct heater on this box. We'd just use another side loop here. We'd use analog to binary control, temperature based. We're going to use existing because it's already over there. Heating, and hit OK. Finish. Heat. Boom. There's our heating command right there. Here is our program. We do need to tie in our process variable, make a connection on temp. And see, you have a different heating set point up here. So you can go into there and change it to whatever you want heating to be. And that heat will work off of that. Same thing if you had a fan power box, we just tie a fan command into this heating program and the fan would come on at the same time. Okay. But now say you're hooked to a rooftop unit that actually outputs heat. You don't want your damper acting in cooling fashion when it's blowing hot air, right? So no problem. We can do one or two things. We can get a signal from the unit itself and reverse the action of the PID right here, direct acting to false. Or we can look at a discharge air temp, DA-T, or a supply air temp, SA-T. So a supply air temp would be before the heat strips. And we're just going to choose a nickel sensor. Now we'll just do a 1K, 10K type L. 10K type L is 10K type 2. So we got a supply air temp sensor right there. And we just have to do a little bit of logic. So we're going to go mode. So let me look here. True. Okay. View logic. Obviously, we're going to bring in our float, and that is going to be our supply air temp. And then I'm going to bring in a less than value. So I'm going to compare less than. And let's just bring in a constant float. And let's call it, what, 65 degrees? Yeah. 65. All right, so when the supply air temp is less than 65, we're going to be direct acting. And when it's above 65, we're going to be reverse acting. So let me just grab an activity boolean. Should work perfectly. And call this mode. Set my output to mode. All right. Now I'm going to make my connection to my supply air temp. And then over here, I am going to make my connection to here. Now, let's watch and see if this works. So if I simulate it, save changes, no. Supply air temps at 55. Zone set point is 72. Let's make the zone temperature 74. So our damper starts to open. Start simulation. There we go. Now we're simulating. Now you see our damper is opening here because it's warmer than the set point. And we're getting cold air in. So let's see. Well, let's watch it open a little bit more. We're good. Too crazy. There we go. See, it is opening. So what happens when we raise this above 65, when we start blowing 80-degree air? Now our damper should start closing because we just went reverse acting. So we're hot in the room. Our set point is lower than our temperature. we should actually close the damper. And we are. See, we went from 28 to 26. Let's see. It's not a super fast PID, but it doesn't have to be. It's for room temperature. Room temperature doesn't change in an instant. There we go, 26 to 24. So you see, we just built the program, and then obviously if we got too cold, 66 degrees. Our mode's off. We do have to tell our mode to turn on over here. It should go off at 71. Yeah, there it goes. So we do have to fix our mode because it built a state table for us here. So we can either have an occupied up here, or we can just put it in control all the time. But this would work for a pressure dependent system, figure. I mean, the proper way to probably do this would be actually throw an occupancy in here. Then this would be schedule apply, default value occupied. That's cool. We come down here, state tables, we would edit. We would, let's just create that table, delete that table. We're going to create a state selection column, state table. We're going to call it awk. And we want awk schedule. We're going to make it top priority. Okay. Now, when we're occupied, we want this to be in control. We want this to be in control. Unoccupied, we want that off. We want that off. Standby, we get to choose. We'll just go ahead and throw it in control and standby, and not set, we'll go ahead and throw it in control. And that'll take care of all that. Now we hit apply, and we just have to connect our occupancy to our state tables. And now we can run that simulation again. Save simulation. Start simulation. Hopefully it starts faster this time. Sped that up because it takes forever to go in simulation now. But now, if we look at state tables, now we're going to control. So our temperature drops below our set point, our heating set point, and we turn on the heat. If it drops, goes above the differential, and we come out of heat. So that's how you could build a pressure dependent VAV box just with the side loops and just maybe a little bit of custom programming here and there. Thanks for watching.